Okay, normalization, basically what we do is we look through all the data and we find the maximum value, and then we divide that value, we divide all of the other data by that value. So let's say that if the population was 16 million and that was the maximum one, we would just divide everything by 16 million, and what it would do is it would give us a percentage value. So for example here, the idea is this vacant housing units by the total number of housing. So it tells you the percentage of vacant units. Okay, so the comparing the number of vacant to the total number of housing gives you the percentage of vacancy. Okay, and dividing a population by area tells you the population density. So if there's 20 people, are those 20 people scattered all over 5 miles, or are they scattered all over 50 feet? So where is the population high relates more to population density than the population number itself. So this is unnormalized data. So this says these are the vacant housing units. And you can see that New York and Texas and California look horrible. We have all these vacancies in housing. And Montana looks pretty good. So don't have very many vacant housing units there. So that looks like a pretty good thing. So the information here really tries to draw you down to that these states are quote-unquote kind of bad. But when we normalize the data, when you divide it by the total number of housing units, so you can see this is a little bit different. So it's vacant divided by housing units. And now when you look at this, you see that, boy, California is great. The percentage of vacant units is very, very low. So while it looked bad in the last information, it looks very good in this information. Correspondingly, Montana looks pretty bad because we've got a lot more vacancies, and frankly, Maine, they weren't even in the race the last time around. Now Maine is up here with a very high percentage of vacant units. Here's the population. So when we look at non-normalized data, we look at the population. Certain counties look pretty good. So I mean, it looks like there's a lot of population here and in this centralized area and so on. So that's the population by county. But of course, these are really big counties. So let's see what happens next. When we normalize this data, you can see that the population density is kind of what we would expect here around San Francisco and Silicon Valley, so on. Population density is very high. San Diego is very high, but as you head up into the mountains and so on, the population density is quite low. All right, I'd like to add to this a little bit of information on color. Hue is the basic color, so we've got red, green, and blue here. And value is the amount of white or black in the color, so we can get a range within a certain color. And saturation refers to a color that ranges from a pure hue to a gray or black. The color wheel provides some guidance in choosing colors. So typically, if you want high contrast, you go across the color wheel. So for example, yellow with violet shows up very well to your eye. Blue and orange show up very well. So that's a guideline in using colors. If you're going to use 3, you would go every third. So for example, orange, green, and violet would work well, or red, yellow, and blue, for example. So you want to equally space, so 4 colors equally space and so on. If you're looking for harmony or subtle differences, then you go around the color wheel. So blue, blue-green, green, yellow-green, and so on. So we would map along this section. If we want differentiation, we go across the color wheel. So when you look at light versus dark here, if you look at this with your eye naturally kind of gets hammered by this view, but your eye will track this way in this information, and it will track down through sort of light to dark, and so your eye will follow that path to get you to the information that is trying to be conveyed. The other thing is to look at contrast. So if I have a low contrast scenario here, which is the difference between the white and the gray, but the black is very, very stark, so a very high contrast scenario. So monochromatic means we're going to stay within the same color range, so it's very common in chloroplath, and then the darker the color, the more important the feature would be. And so here's an example. It's a monochromatic map, and basically your eye is just going to wander, and the reason it's wandering around is because there's not any real high contrast for it to be drawn to. In other words, this variation from light to dark is just not enough to draw our eye. This is a better map, and we've got lighter areas and darker, so it's almost like we've extended both the light side and the dark side. So now your eye gets drawn to the darker areas. For example, this corner of New Mexico, it brings out a question to me is, why are there so many old people living in here, or have all the young people left? I mean, what's happening there? And these two counties here on the border, what's going on with those guys? Florida, we recognize, is going to have some old people, but what's happening up here? So most monochromatic scales, it's kind of a typical thing, but we use two monochromatic and join them together in the center. Now this is helpful if we're looking at like increasing and decreasing. So if the using the middle point as being a 0, so we're going to one color if population is leaving, and one is if population is increasing, for example. So here, forest fires, right? So the smallest number is in the center, and then larger decreases get higher colors, and larger increases get higher colors in a different way. So this kind of allows you to kind of differentiate whether things are getting better or worse in particular areas. So it's increasing in this range here, but decreasing in this range here. Some colors have got political meaning, Republican, Democratic presidential elections, for example, are a very common colored map that we all watch in November. Cool colors give it a little bit more calming, and they appear smaller and they kind of recede away, and warmer colors are more exciting and overpower. So we tend to downplay the cool information and and enhance the warm information. You really don't want to do it as a rainbow. You don't want it to look like a kindergarten map. You want to be careful about the size of the color value, so you want to be a little bit careful there. Here's a series of tips. Here's polygons colored, and you may want to use centroid points, the center of a polygon versus the whole polygon, so which one really gives you more information. So this is the centroid points, and they've been colored, so you can kind of see this area is important. Your eye gets drawn there. So you don't have to, in other words, you don't have to have the entire polygon colored to draw your eye. This actually works better in this case.